Hi everyone, I'm sick today so I can't come in, but I just thought I'd make this video to help you revise for the test, which is tomorrow. If you want to look at it yourself again for revision, it's on my YouTube channel, which is youtube.com/Daniel Searson. Okay, so for the test tomorrow, it covers everything that was in your work booklet, so that includes calculating speed, distance and time, and I'll give you the formula to do those in the test, so you don't need to memorize that, but you do need to know how to use it. You need to know about how to look at acceleration graphs or ticker tapes, just like we've talked about. You need to know how to use the acceleration formula, which says that acceleration is the final speed of an object minus its initial speed, all divided by time. And you need to know about types of forces and Newton's 3 laws of motion. Okay, so what we're going to do now is these are just some revision questions. Now I want you to do those in class, so I'm going to get you to pause the video and I'll get rid of my face and pause the video, have a go at these questions, and then unpause it and I'll go through the answers. Okay, so just hit pause now. Okay, so I'll keep going and go through the answers now that you've had a go at those. So first of all, Usain Bolt runs 100 meters in 9.6 seconds. What is his average speed? Well, we know that the formula says that average speed equals distance over time. I've just used that little slash to mean over or divided by. So that's 100 meters in distance divided by 9.6 seconds of time, which is 10.42 meters per second. Now, that's fine for that answer. You could also change that into kilometers per hour, and to do that you would multiply it by 3.6, but I'm not going to do that because I didn't say that it had to be in kilometers per hour, so meters per second is fine. Second question, a car traveling at 110 kilometers per hour drives for 2.5 hours. How far did it go? So if it's asking how far, the formula we want is for distance, and that equals average speed multiplied by time, which is 100, that should be 110 multiplied by 2.5, I apologize. 110. Now I've written 250, but in actual fact it should be 275 if it was 110. Okay, little mistake there, sorry. Okay, question 3. In a crash test, a car is accelerated from not moving, so it's sitting there, up to 15 meters per second over a time of 5 seconds, and then it crashes into a concrete barrier. So the first question says, when was its biggest acceleration or deceleration? Well, if we think about it, at the very start, it accelerated from 0 up to 15, and at the end, it decelerated from 15 back down to 0 when it crashed. So the change in speed was the same. It went up by 15 and then it went down by 15. Same change in speed. But when it crashed, that obviously would happen in a much shorter time period than 5 seconds. It happens in like a fraction of a second. So the acceleration was actually biggest during the crash, because even though the change in speed was the same, the time it takes to change speed is much, much shorter in the crash. So the acceleration or the deceleration is actually much bigger. And that makes sense because it's, you would feel a crash much more than you would feel just accelerating in the car. Okay, and then we have to calculate the acceleration at the start of the test. So this is when it's speeding up. So we use the formula to do that, which says that it's final speed minus initial speed over time. And that's 15 minus 0 divided by 5. Now remember, because this divide line is for all of the top, we have to figure out what that is first, which is just 15, because it's 15 minus 0. Then we divide by 5, so that's 3 meters per second squared. Okay, question 4. In a crash, a 1,500 kilogram car has a deceleration of negative 200 meters per second squared. It's negative because it's decelerating, so it's slowing down in a crash because it's hit something and it's slowing down really, really rapidly. So what was the force on the car in newtons? And we get a hint there to use Newton's second law, which says that force equals mass multiplied by acceleration. Well, the mass of the car is 1,500. The deceleration or the acceleration is negative 200. And so the force, if you times them together, is negative 30,000. And here's Edward just to say hello and do some physics with us. Okay, so thank you. Question 5. A bus is rolling down a hill with its engine off. Okay, so part A, list the forces that are acting on the bus. So there's 4 forces that I can think of. Okay, so first of all, there's gravity, which is pulling the bus down the hill. So remember, anytime we're on Earth, we get pulled towards the center of the Earth. So if we're on a hill, we'll get pulled down the hill. There's some air resistance at the front of the bus, which is slowing it down. There's some friction on the tires, which in this case is slowing it down. If the bus was like using its engines, then that friction would be speeding it up. But because it's not using its engine, that friction will be slowing it down. And then there's some physical contact with the road, which actually holds it up. Now, this is the weirdest one, and remember, it's because of Newton's third law, which says that there's a reaction for every action. So because the bus is going down against the road, there's got to be a force holding it up. Okay? And that's the physical contact with the road. And then part B says, according to Newton's first law, what must happen for the bus to slow down? Well, we know that if anything's going to change its speed, i.e. if it's going to slow down, we know that a force has to be applied. That's what Newton's first law says. So if the bus is going to slow down, a force has to be applied for it to change speed. Now, if it went for long enough, maybe the friction on the tires might slow it down, but realistically that might be like the braking force, which would increase the friction with the road, by the way. So braking force, or if this bus unfortunately hits something, then it would be the force of it hitting something that would make it slow down. Okay, I hope that makes sense and is useful. That's all for today, and I hope you got those questions right. I'll see you tomorrow for the test. Thank you.